Hello, I will introduce our paper, IAFMNet, Information-Aware Feature Modulation for Efficient Image Super Resolution. Firstly, let me introduce the motivation of our work. Efficient single-image super resolution aims to reconstruct high-quality images under limited computational budgets. However, different image regions have different reconstruction difficulties. Smooth areas are relatively easy to recover, while textures, edges, and repetitive structures usually suffer larger reconstruction errors. Existing efficient senior methods often rely on uniform processing or heuristic region partitioning. Therefore, we aim to identify difficult regions in a more principled way and allocate more computation to them. Our contributions are summarized as follows. First, we propose an unsupervised information density map, or IDM, to identify reconstruction challenging regions from an information theoretic perspective. Second, we introduce IAFMNet, an information-aware feature modulation network for efficient super resolution. It combines explicit sparse resource allocation and implicit affine feature recalibration. Finally, extensive experiments show that IAFMNet achieves a better trade-off between reconstruction performance and computational cost. Next, I will introduce how we estimate the information density map. Our method is inspired by information theory. Given a signal with probability distribution p of x, its information content can be measured by the negative logarithm of its probability. In other words, low probability signals usually contain more information and are more difficult to encode and reconstruct. Based on this observation, we model the probability distribution of quantized shallow features and compute their element-wise encoding costs. The information entropy loss is optimized in an unsupervised manner, and the learned scale map is used as the information density map. Regions with higher encoding costs are regarded as information-rich and reconstruction-challenging regions. As shown in the visualization results, traditional edge operators, such as Sobel or Laplacian filters, mainly respond to local gradient intensity. However, reconstruction difficulty is not solely determined by edge magnitude. In contrast, the proposed IDM captures more informative textures and structural patterns beyond simple edges. As shown in the figure, high-response regions in IDM are highly consistent with the reconstruction error distribution. These regions usually correspond to repetitive structures, dense textures, and complex edges. Therefore, IDM can provide more reliable and interpretable guidance for adaptive feature enhancement. This slide presents the overall architecture of the proposed IAFMNet. Given a low-resolution input image, we first extract shallow features using convolution layers. Then, the information density estimator predicts the IDM from the extracted shallow features. The estimated IDM is subsequently shared across multiple information-guided feature enhancement blocks. Under the guidance of IDM, the network adaptively enhances informative regions while avoiding redundant computation in smooth areas. Finally, the enhanced features are reconstructed into the high-resolution output image through convolution and pixel shuffle operations. The core component of our framework is the information-guided feature enhancement module. Specifically, we designed two complementary branches. The first branch, namely IGERA, performs explicit hard resource allocation. According to the IDM, the network selects the most informative spatial locations and applies sparse convolution only to these regions. Unlike conventional convolution, which processes all spatial locations uniformly, our sparse convolution concentrates computation on reconstruction-challenging regions while bypassing redundant smooth regions. The second branch, namely ARM, performs implicit soft feature modulation by generating affine modulation parameters from IDM. Together, these two branches provide both hard and soft guidance for efficient feature enhancement. To further understand the effectiveness of IDM, we visualize the intermediate feature responses during the enhancement process. As shown in the figure, the network gradually focuses on texture-rich and structurally complex regions, under the guidance of IDM. Compared with baseline features, the enhanced features become more concentrated around informative regions such as repetitive structures and sharp edges. We compare the proposed method with several state-of-the-art lightweight super-resolution methods on widely used benchmark datasets. The results demonstrate that IAFMNet achieves strong reconstruction performance while maintaining low computational complexity. For example, under the x4 super-resolution setting, our method achieves competitive PSNR performance on Urban 100 and Manga 109 with only two 20K parameters and 11G flops. These results validate the effectiveness of the proposed information-aware computation allocation strategy. This slide presents visual comparisons with other efficient super-resolution methods. Existing lightweight methods often produce blurred structures or distorted textures, especially in regions containing dense lines and repetitive patterns. In contrast, the proposed IAFMNet reconstructs sharper edges, clearer textures, and more faithful structural details. The visual superiority is particularly evident in texture-rich regions, where our information-aware enhancement strategy can better preserve structural consistency. We further conduct ablation studies to analyze the effectiveness of different components in our framework. First, replacing IDM with traditional edge-based guidance leads to noticeable performance degradation, demonstrating that IDM provides more reliable reconstruction difficulty estimation. Second, the proposed information-guided sparse convolution significantly improves reconstruction quality with only a small computational overhead. Third, introducing IDM-guided affine recalibration further enhances feature representation and improves reconstruction performance. Overall, these experiments verify the effectiveness of our information-aware feature modulation strategy. In conclusion, we propose IAFMNet for efficient single-image super-resolution. Our key insight is that image regions exhibit non-uniform information density, and informative regions should receive more computational resources. To achieve this goal, we introduce an unsupervised information density map derived from information theoretic encoding costs. Under the guidance of IDM, the proposed framework combines sparse resource allocation and affine feature modulation for adaptive feature enhancement. Extensive experiments demonstrate that IAFMNet achieves a favorable balance between reconstruction quality and computational efficiency. Thank you very much for your attention.